So I would like to accomplish two things today. Actually, three things today, really. Okay. So first thing is I want to go through some speed chart example problems. There's three of them today that I'd like to go through. So that's the first thing. We'll take a little bit of notes at the start of class. Second thing is we are taking a formative today. Okay. So we'll take that formative in the middle section of the class. And then the third thing is you've got a worksheet from last Thursday, and you picked up a worksheet today as you came in. So then give you time to work on those worksheets, get questions answered, etc., etc., etc. Okay? So the first thing is you should have watched a video at some point in time since Friday, actually since Thursday, because I posted it on Thursday afternoon. Okay? So you should have watched a video at some point in time since Thursday before today that dealt with the speed chart. Okay? So we have three different kinds of speed. That's why we call it the speed chart. Okay? Should have a picture of Lightning McQueen up here because this is speed. Okay? Okay? So we've got rotational speed. That's speed that you're going around on an axle. Okay? So rotational speed is how many times you are rotating per time frame. Okay? So that's going to be in revolutions per something, per time. Okay? Then you've got angular speed. How many angles is a point going through as it rotates around on this circular object? Okay? So that's angular speed, and that would be radians per amount of time. Okay? Or if you convert it into degrees, it would be in degrees per amount of time, but that's angular speed. Okay? And our last one is linear speed. Linear speed is all about how fast you're going. So in a point that's on that object that's moving, how fast it's moving. Okay? With all of those, we can convert those into distance. Okay? So we can go through all of those. So if you're given the rotational speed and you're asked to find the distance, you have to go through angular speed, then to linear speed, and then to the distance. Okay? Once you're in this chart, to go somewhere, you have to go through the other ones. Okay? So here is example number one. Example number one says, a truck wheel with a diameter of 36 inches. Okay? So that's something that we should probably highlight here, that our diameter of our wheel is 36 inches. Side note, the double dash, okay, that's inches, single dash, that's feet. Okay, so that's saying diameter of 36 inches, rotates at 630 revolutions per minute, or RPMs. Okay? We want to find the speed of the truck in miles per hour. Okay? So the wheel is rotating at 630 revolutions per minute as it's going down the road. I want to know how fast that truck is actually going. Okay? Well, in purple, we were given revolutions per minute. Bless you. We want to get that into miles per hour. Okay? That's what it says right here. Miles per hour. Okay? So, first thing, what kind of speed do I have? I've got what? Rotational speed, okay, that's revolutions. So I'm at the top of my speed chart. I want to get to linear, which is 3 down. Okay? So first I have to go to angular speed. So I need to change this to an angular type of speed. So my conversion is, I would need some revolutions because I need to cancel it out. Okay? And I need some radians because that's angular speed. Well, how many revolutions or how many radians are in a revolution? 2 pi radians in how many revolutions? 1 revolution. Yep. Okay. To go around a circle, it's 2 pi radians. Now, I'm in angular speed. So now I need to get it into, according to my speed chart, I need to get it into linear speed. Okay? Well, in order to get it into linear speed, I'm going to convert my radians into some form of linearness, some length. Okay? So how much is 1 radian equal to in this problem? Sammy whispered 36. But she is unsure of herself. Why 18 and not 36? 36 is the diameter, right? We need a radian is a radius, so we got to get it into the same thing. So I would go here, yes, 18 inches is a radius. So that means 18 inches is a radian. Okay? So now we're in inches per minute. Yes? And that's linear. Correct? But is it in the proper units that we want? No. Okay, so now we got to do some regular old converting. Okay? Do you want to convert inches into miles first? Or do you want to convert minutes into hours first? Minutes and hours, okay. Minutes is on the bottom, so that means I'm going to say minutes on top, hours on the bottom. How many minutes are in an hour? 60, so this is 60 over 1. Now I'm in inches per hour. I need to be in miles per hour. So inches to miles. Anybody know the straight up conversion, inches to miles? Good, neither do I. Okay, so we got to go piece by piece then. What's the next biggest unit above an inch? A foot. Okay, how many inches are in a foot? Whoa, you know. Okay, so now I'm in feet per hour. Do we have a conversion feet to miles? 5,280. Side note, if you don't know that there are 5,280 feet in a mile, it's one of those that you should just flat out memorize. Okay? 5,280 feet in 1 mile. Only labels that I have left should be miles per hour. Do we agree? Yeah, I agree. Okay. So that tells me that we've got 630 times 2 pi times 18 times 60 times 1, all divided by 12 times 5,280. me. 1360800 pi. 63360. I get that the truck is going 67.473 miles per hour. Yes? Concur? Or just agree? Oh, do it. You got it right there. Yeah. So then, yeah.
A lot.
I know. But that's what we got to do. It's really not that difficult.
No.
It's just there's a lot of it to do. Yep. Yep. Factor label conversion. Okay. Questions on that one? Make sure I gotta scroll down and make sure that there's no, like, how many miles does it go in X amount of time. Okay. Right. You try this one now. A bike with a 28-inch diameter wheels is racing at a speed of 36 feet per second. How many revolutions per minute are the wheels making? Now I found it. Okay. So our start one is 36 feet per second. I want to be at, and this is a nice thing too, you know you're done when you're at revolutions per minute. Until you're at revolutions per minute, you're not done. Okay? So, that's linear speed. So the next thing that I would do is we got a 28-inch diameter. I'm in feet, so I need to convert this into 1 foot is 12 inches. Now I'm in inches, which is what I need because my diameter is in inches. I couldn't use my diameter until I got it into inches. So that means 14 inches is 1 radius, which is also 1 radian. So now I'm in radians per second. 1 excuse me. Tap it right. I was going 1 there. 1 revolution is 2 pi radians, which is 2 pi radius, which is 2 pi radii, which is my RAD. So now I'm in revolutions per second. There are 60 seconds in 1 minute. Now I am in revolutions per minute, which is what I want to be in. On top, we get 36 times 12 times 60. On the bottom, we get 14 times 2 pi. Who told me wait? Oh, okay. Did you get it?
Yeah.
Yep. On 36 times 12 times 60 would be 25 at 9. 9 920 over 28 pi, which is 6,480 divided by 7 pi, which is 294.664 RPMs.
Wait, how'd you?
Because you rounded a little bit earlier. Yep. How did I get what?
Wait, maybe I just.
Yeah.
So when you're typing this in, so if you're typing either one of these two in, these denominators have to have a set of parentheses around them. On any one of those three, you gotta, after the divide sign, you gotta have parentheses. Because otherwise what it's doing is it's taking it and just dividing the very first number you put in there and then multiplying that whole thing by it.
Is it a coincidence that it was feet on top and then it was feet on bottom, and it was radians on top and it was radians on bottom? And then,
Yes.
like, that's coincidence?
No, that's how it's done.
Okay.
Because that's how you gotta cancel out the
You al-
labels.
But you always take what's on the top first?
No.
To get rid
Oh
of
no. We could have jumped in right here at the start and put this very last one first and went feet per minute and gotten the minutes out of the way right away.
Okay, but if I choose to do the feet on top and feet on bottom, then do I follow top to bottom across until I get my answer? Or is that like?
Well, yeah,
not
because that would be the only place that you would have, until you move the, you know what I
You
mean?
have to have the top and the bottom to cancel.
Yep, to cancel them out.
Well, right, but it doesn't matter which one I go for
No.
first. Okay.
Nope. Okay, one more. During the spin cycle, my washing machine rotates at 1,400 revolutions per minute. If the drum has a 27 centimeter radius, what is the speed? This is a Mrs. Hill type one, that's why it's Grant. Okay. At what speed is Grant's lost sock spinning in miles per hour? Okay. Follow-up question. I see that there's a follow-up question down here. What is the distance that it traveled in miles? I'll move this up here just a little bit. I think I can. What is the distance that it traveled in miles during the 15-minute spin cycle? Go.
Wait, what?
I'm listening.
Oh, so for inches to radians, so like for one of the first problems we did, it was 18 inches is 1 radian, and then the one before this, it was 14 inches, it was 1 radian. So was there like a certain like inches to radian like equation that we should do? So whatever your problem is.
All right, here we go. So we started with 1,400. Oops, come on now. We started with 1,400 revolutions per minute, correct? Okay. So we want to get it into miles per hour. So 60 minutes is 1 hour. At somewhere along the line, you're going to need that one because we need it to be in hours. Okay. 1 revolution is 2 pi radians. You need that one at somewhere along the line. 1 radian is 27 centimeters. You'll need that one somewhere along the line. Again, these can all be in different orders. $1 inch is 2.54 centimeters. Now I'm in inches per hour. 12 inches is 1 foot. There are 5,280 feet in 1 mile. Only thing left, miles per hour. Okay? So on top, I've got 1,400 times 60 times 2 pi times 27. On the bottom, I've got 2.54 times 12 times 5,280. I get on 100 times 60 times 2 pi times 27. On the bottom, I got 2.54 times 12 times 5,280. And I get approximately 88.547 miles per hour.
Oh god, no, I couldn't see it.
Okay. So that's the speed that it's traveling at. How far did it go in a 15-minute spin cycle? Well, if it's traveling that long in an hour, so in 1 hour it would travel 88.547 miles, correct? So I can divide that by 4, and I can figure out, because 15 minutes is 1/4 of an hour, so I could multiply by 1/4 or divide by 4, and I would get the fact that it traveled, that sock traveled 22.137 miles in the spin cycle without ever leaving the washing machine. 1/4 of an hour. Just divide by 4. Or the other way that you could have done it, Landon, is on the tail end of this. I'll put it in this color because I'm in miles per hour, right? So 15 minutes is 1/4 of an hour, and now I'm just in miles.
Okay.
Same thing.
Okay.
That's where the divide by 4 came. Okay? Goal number 1, or object number 1 of the day, done. Object 2 now, formative. So you will need out a writing utensil and a calculator.